Today I'm going to talk about some of some two big trends or areas of activity, especially in the Silicon Valley around education. And mostly I'll talk about AI and personalized learning, and a little bit less about design thinking. If we have time, I'll talk about that in the end. So first of all, I want to thank my students, my graduate students who helped me with a lot of the content in this presentation, Chris, Richard, and Engin. And so I want to start with this illustration from 1899, 119 years ago. So this is a Parisian artist who was imagining lots of aspects of the future, cars, houses, and education as well. So this is how he imagined education in the year 2000, as you can see there. So there are these books that are kind of ground in this machine, and then it goes into this magic headphones to the heads of students that just sit quietly with these machines learning all this stuff that was in the books. And you know what I think is interesting in this illustration is that this is a really it's a recurring theme in education and a recurring solution for classrooms, which is I mean, how can we automate things? How can we make things more efficient? And this is the kind of solution that, even though this was just an artistic rendering of an idea, that's a solution that has been with us for many, many decades. And I'll show you some other examples. For example, in the 1920s, radio was that magical machine. So you can see here, with radio, the underprivileged school becomes the privileged one. And they had this radio classrooms where people could, broadcast, teachers would broadcast lectures, and then kids in underprivileged schools could have access to the best teachers through the radio. Then, that didn't work quite well, but then the TV came along. So this is from the late 1950s, and then people were like, oh, okay, now we really have the whole thing, the whole package, not just the audio, but the image too. And TV learning or TV teaching would democratize education and make the underprivileged schools the privileged ones and all of that. But that also didn't quite work as well as people were hoping. But then there was this thing that people started using together with those devices, which were calling teaching machines. So those machines were basically, we'll see many examples of that, were machines that asked questions, and then you had to answer the questions, and you couldn't move to the next question until you got the question right. And then you can see, like, will robots teach your children? So the robots were like this kinds of machines, question and answer machines that we call it teaching machines. This is the inventor of the first one, Prusset. So it was basically a test-taking machine. And then this also became, became many consumer products. So this is one example of this spelling game, time telling, and lots of math machines where you have this templates with the questions, and then you have to answer the questions, turn the knob. If you get the questions right, you can go to the next one. And so the idea is that you get what people would call today mastering. Something you have to get all the questions right in order to move forward. And there were many types of those machines. Some were computer-based. So this used 35mm colored slides to show people the questions or some of the lecture. There were like sound-based ones, there were some more sophisticated ones, even like a driving machine, kind of a motorbike simulator kind of thing, that you'd stand there and then you had to answer. There was a little screen that showed you situations in traffic and then you had to answer the question. So, very sophisticated stuff for the time. And, what I want you to start noticing in this next few slides is the kind of discourse that shows up. So this is all from the 1940s and 50s. So, you learn fast with the, teaching machine and what a teaching machine can do for your child. So this, would you care to experiment? So this is a school that was experimenting with one of those machines. So it's that with the aid of a channel selection at each desk, the student can bring in any one of 3 lessons pre-recorded in a plastic belt. The system allows students to work at their own best learning rate and frees the teacher for individual tutoring. And then, what are the values gained by the time-saving automated classroom? First, teachers will be able to pay more attention to the broader aims of education than the mere repetition of facts and dates. Second, enjoying the stimulus of constant check of progress and the pleasure of being rewarded promptly when his work is correct. The pupil has a feeling of accomplishment. And then if you look at some other things, according to the specialists, the teaching machine, far from making teaching less personal, it will make it more so. The machines leave the teacher free for more creative aspects of teaching, including more individual attention to students and more conferences with the parents, and etc. So if you look at those magazines from the 1950s, what's I think really interesting is that you start seeing the kind of language that's very familiar today. So, for example, the teaching machine takes advantage of 3. Like students learn best when he learns at his own rate of speed. He learns best when he's immediately made aware of his right answers, and as he gains confidence in his account. But the first one is one that's particularly popular today, and when you read about personalized learning, is this idea that students should learn at his own rate of speed. So
this, sorry, Paul.
Yeah.
This that he learned when he's immediately get the right answer, it still holds true.
Well, we'll see about that. I mean, I'm not saying any of this is true. I'm just showing how people used to talk about those things.
No, sure. I mean, just out of curiosity, if this still holds true, I mean, it's good to know right away the right answer.
Not necessarily. So let's see this. So now I want to kind of jump 50 years in time, and we'll watch this 2-minute video of something called Dreambox, which is one of the most famous and popular systems for personalized learning. And so I want you to see if you notice any similarities between what people were talking about 50 years ago and what they talk about in the video. And let's hope the sound works.
Educators, we know that every student comes to class with a different level of math ability. Yet we teach a single process to an entire class at the same time. To give the best possible education to my kids, we actually need a teaching assistant for every student. We looked for math software to help. I found that many programs took a typical lesson and just converted it to a digital textbook. Another claimed to be adaptive, but all it did was move students faster or slower through the exact same lessons. But one was a revolutionary change: true adaptive learning. Dreambox is the only program designed with an intelligent adaptive learning engine. It starts helping students immediately, and continuously assesses exactly where students are and adapts to how they learn in real time. Dreambox measures how students are thinking within the lessons, constantly individualizing what each student sees next. In fact, as a single student works on Dreambox for 1 minute, the program collects, analyzes, and responds to over 800 pieces of information about that student and how they learn. That's 48,000 pieces of data every hour, providing the most personalized learning experience possible. The results are amazing. The kids love it. They think Dreambox looks like a game. I think it looks like a teaching assistant for every student. A teaching assistant with infinite patience, unlimited data, and a perfect memory. With the help of Dreambox, I can give each of my students the education they deserve. It's time to learn more. Start now.
So, let me stop for a second. And so, what do you see? Do you see any similarity between what I was talking about before and this video, even though they're separated 50 years?
I saw the adaptive argument and the one that teachers would be able to focus on other parts of the teaching.
Right. Yeah, so that's a very, very clear message is that by automating all this stuff, then teachers can do the more creative stuff or focus on other parts of the teaching that's not the part that's being done by the computer. And that was almost like exactly the same that they were saying that the machine can take care of in the magazine ads. The machine can take care of that, and then teachers can, take care of other things. So what's your guess about did that actually come true? Since we have a sort of a time machine here, because we can look what people were saying 50 years ago. And so did that happen? Like teachers got more time to work on more creative things, or?
The reality that I've been part of, no, at least like in public education in Brazil, you don't have it's not every time, every class that you have access to this kind of tool. So it's more like one fun class for students.
Right. Yeah. So that's a good point, and we'll go back to that, like what happened in all of those things. But let's just move forward a little bit. So this guy Larry Berger, he is the CEO of probably the largest company that does this kind of personalized learning. I think it's called Amplify. It's a kind of like $1 billion company that's very well funded, and so this is how he kind of summarizes how those systems work. You start with a map of what kids need to learn, then you measure the kids and place them on the map. Then you assemble a vast library of learning objects and ask an algorithm to sort through and find the optimal learning object for each kid at a particular moment. Then you make each kid use the learning object, then you measure the kids again. If they have learned what you wanted them to learn, you move them to the next place on the map. If they didn't learn it, you try something simpler. If the map, the assessments, and the library were used by millions of kids, then the algorithms would get smarter and smarter and make better, more personalized choices about which things to put in front of kids. So this is like one of the best summaries I've seen about how those systems, the idea of those systems is that you have this learning object, so it can be, videos or some kind of mini lectures, whatever, and you have a map, and then kids are advancing through the map, and you're constantly assessing the kids to see where they are on the map. If they are falling behind, you give simpler stuff, and then supposedly make them advance, maybe in a different way or at a slower pace. And then there's kind of big data algorithms are optimizing the system constantly. Right? So it sounds like an amazing thing, because as you were saying, teachers can focus on different parts of teaching, not this kind of repetitive things. But the problem is that people started implementing that in many, many schools because there was a lot of money, funding companies like Amplify, but also many other companies, and the results were just not. Oh, sorry. Am I in the wrong place?
No, it's just it's too close.
Should I put it? It's too close.
To the laptop, it's a little
Should I put it here?
That'd be better.
So, one of the big experiences in this thing called School of One, which was a company like about 5 years ago that later became Amplify, was a very famous experience. And I remember people from Brazil were, like 5 years ago, 6 years ago, were coming here all the time to visit the School of One, which was an experiment, accompanying an experiment in New York and in other places. But people would come to the U.S. and visit New York, and there was a lot of buzz about this. And then it didn't work. So this is from the press when those schools in New York abandoned the project after just 1 year. And then they kind of revamped the whole thing and tried again using tablets. And then this was like a $500 million, revamping of School of One, and then they renamed it to Amplify. And again, it didn't work. Then there was another experience that you might have heard about, Coursera.
Sorry, Paul. What is this school of? I didn't understand.
School of One was it was a software.
It's just a software.
It's a software that was being implemented in schools. It was a software and a way to organize a classroom, right? So, which is used in many places. If you have kids in front of computers or then tablets, and they have the lectures on the computer or on the tablet, and then they have quizzes and tests that they have to answer as they go through the videos. And so it's kind of personalized learning thing. It's like you watch a video, you do a quiz, and then you move forward, or the system tells you to watch another video or move forward or backward, and all of that. So School of One was one of the first, and then it was renamed as Amplify, the company. But those, it's the software, but it's also a way to organize the classroom. So, for example, in some schools, instead of having 20 students, they had like 40 students, and because they could get more out of the same hour, and then so they were hoping that it would be more productive. You could have more kids in the classroom learning the same. So is that? Yeah. Okay. So then another in higher education there was this very high-profile experience called two companies here out of Stanford, Coursera and Udacity, and they too had problems. So Coursera kind of pivoted to job training, and so it's funny, like they say, learning for the sake of learning sounds nice but doesn't pay. MOOCs will not transform education. Original claims are overhyped and unrealistic. And a lot of these companies pivoted to more like money-making. Different business models, mostly corporate learning, job training, and things like that. So the idea that you could get a college degree out of Coursera or Udacity didn't quite work, especially that you could get that for free and anywhere in any language at the same kind of quality that you could. The attrition rate was 94%, so people were dropping out in huge numbers and all of that. So, we could go into detail about any of those, But I want to go back to that same guy, Larry Berger, who is the CEO of Amplify, because he's the maybe most unbiased voice in this, because he has all the incentive to defend and this kind of stuff. And in a recent talk, he said this. He said, here's the problem with personalized learning and AI in education. The map doesn't exist, the measurement is impossible, and we have collectively only 5% of the library. And because the algorithm, and just because the algorithm wanted a kid to learn the next thing doesn't mean that the real kid actually wants to learn the real thing. And to be more precise, the map exists for early reading and quantitative parts of K-8. And much promising work has been done in these areas, but the map doesn't exist for reading, comprehension, writing, for more complex math, and any area of science and social sciences. And we weren't sure whether you should learn about proteins and genes and traits, or traits and genes and proteins. So this was a kind of a game-changing talk that Larry Berger gave. It was just a few months ago, and it's one of the first kind of admissions that things are not working quite well. And there was a lot of talk about in his previous quote that I showed, how we'll build a map and then we can put kids on a map and see where they are and all of that. But in practice, that turned out to be much harder and much more laborious and expensive than before. So I want you to stop and ask you, why do you think this is the case, and why you think we only realize this now and not like for the past 5 or 10 years? That's how long people have been trying to do it.
Well, from the AI perspective, I mean broad AI perspective, the first one seemed like a rule-based system. Although it was very complex, it was just playing or solving a bunch of rules. And this one sounds more like reinforcement learning, which I believe is more related to this. It's not in a single action that you should reward the kid or not, but there's a whole trajectory because of the complexity of the action, the results you want to achieve. So there are several paths you can reach a given overall goal, and it's not one action that should be rewarded or not. You have to wait a bit and not have a set of predefined ways of trajectories.
Yeah, so that's one of the important points, is like the AI and the computer science behind this, reinforcement learning, or are things that work well, for example, to recognize, for image recognition, right? So you feed an algorithm with 1 million pictures of cats, and then the system kind of learns what a cat is, and then it can recognize cats in photos or videos and all of that. But so a lot of people who were working in AI, they had this idea, if we can do these complex things like recognize, do this fancy image recognition things and this other fancy AI things, why can't we do it for education? Right? But what they learned over time is that for very simple things like someone learning arithmetic, which has a very limited set of errors, it's possible to do it because the kind of tree, the combinatorics of actions a child can do is limited, right? But as soon as you start with anything more complex, instead of, let's say, 10 different paths, you have like 1,000, and then it just becomes 100 times more complicated to build a model of that. And either people didn't know that it would be that hard, or they knew it, but they didn't want to tell their investors that they would need 100 times more money to do the next step. But I think that's one of the problems, that it was easy to build a demonstration software to say, oh, look, this kid is learning arithmetic or basic math or something very, and we can have this tutor kind of help. So that was possible, and it does work in certain ways. But as soon as you go, it's kind of non-linear. When you go to 5th grade math, it becomes intractable. But in any case, we'll go back to that issue. The other thing is, building this library of objects turned out to be much more expensive, because it's not. Initially, people thought you can just like videotape lectures, but then realized, well, that's not. Lecture is the worst thing for, is the most traditional pedagogy. It's not. You need more interactive things, for example, stimulations, animations, or other kinds of things, and those are more expensive than just videotaping a lecture, right? You need a designer, you need a certain people working on each of those topics, teams of people and all of that. Anyways, and then it also addresses this issue that, it's not because you put a kid in front of a computer watching a video that the child cares, and that was also, something that people thought would be simpler. But in any case, so let's look at some of the issues that happened. First, that those were standardized and individualized environments where it was one child in front of one computer, and the contexts were reduced to what could be measured. So you didn't have essays, people writing essays or solving complex problems. You had people answering multiple choice tests or kind of fill in the blanks with a number, because that's what the computer can understand, right? And then this idea of mastery that I mentioned in the beginning was basically reduced to, getting the questions right. So you master something when you get a streak of questions right. When you get the questions right, you understand the concept. That was the idea. But then, from cognitive science and learning sciences, we know that that's not necessarily the case. That because you answer a question right, you know the concept, especially if the questions are not well designed, or if people understand how to game the system. If you can get really good at answering multiple choice tests, even if you don't understand the concept. You just eliminate the absurd items, and then you guess under. So there's the nature of the questions. There is this idea of the linearity of the model, which is it was just a linear model. If you get 5 questions, you learn 50%. If you get 10, you learn 100%, and it's not. And also like how you transfer them across concepts. But a really important thing was that a lot of the prediction that AI systems do, and if you work with AI, it doesn't have a causal model. So, when the cat example that I gave before, the computer really doesn't know what a cat is, or even if a cat is an animal or is a mammal. It just knows. You train this kind of neural net, or this basically you brute force learning in a way. You give a million examples, and then the computer kind of learns with a certain probability that this is a cat. But there is no real conceptual understanding about, if you ask the computer what is a cat, it will show you some numbers and say, oh, this is, a cat. But it's so in learning, it was the same thing. Maybe kids were getting something right, but they didn't know what was. You couldn't get out of the algorithm any kind of causal explanation about what was going on. And it's especially important in education to know why, because it's if you don't know why, it's really hard to know what's the next step. Right? You can do what many systems did, which is to just give people more tests and try to place them in a map. But as we said, we saw before, it's not that easy. And for example, in medicine, you do use AI, for example, for mammograms, right? Or like you have this amazing systems that you feed like 500 million mammograms to an AI system, and they can detect breast cancer much better than any doctor. But the decisions are not made by the computer. So the computer shows the results, and then there's a human that's making decisions based on that. Right? So, and that's, you know, another issue is like how AI works is that AI is always paying attention to minimizing some kind of function. So it wants to, for example, when you're using Facebook, the AI, the algorithms, they want to maximize your engagement. So how much time you spend on the platform. And sometimes weird things happen. For example, there are many examples of people who had some kind of psychological disorder. They had some kind of paranoia, or they were depressed, and then the algorithm figured out that if by showing some kind of depressing images or posts that were a bit more depressing or a bit more paranoid or whatever, you would increase the engagement. People would stay more time on Facebook. I mean, the programmers, they didn't know exactly, they didn't intend to make that happen. They just said, okay, do a bunch of stuff and pick the strategy that keeps that person, engaged for the most time. So there was this kind of generic rule, but the programmers at Facebook, they didn't know exactly that, what the algorithm would do and what kinds of psychological disorders they would prey on and all of that. So that's, again, the problem with algorithms is that, they are continually improving on some kind of metric, but they might be damaging other metrics. So for example, maybe they are improving on their math scores, but they're feeling miserable, or they hate math, or they hate school, or but the algorithm doesn't know any of that because it's trying to optimize for one particular thing. And a good example of that was, there was like a few months ago, some weird stuff happened on YouTube Kids, that some weird videos happened. So there was this, a video of a claymation Spider-Man urinating on Elsa from Frozen, and Nick Jr. characters in a strip club, and weird that were going through the filters that were not being caught by the YouTube filters. And then people from YouTube said, well, this is the needle in the haystack. Algorithms decide what's not appropriate for kids, and the video continually we use a lot of machine learning, but it was clearly not working perfectly. But in some cases, it's okay for 99% of, for example, if you are doing like restaurant recommendations and you get something wrong, and you end up in a restaurant that's closed or that's not really good, no one gets hurt, right? It's okay, you just say, well, I'll go to a different restaurant. But, there are some cases where you want 100%. And then the thing is, education is one of those things. You can't kind of say, well, we're going to train the algorithms on kids for a few years, and then maybe later they will be... and so the question, becomes like, whose kids will we train the algorithms? Like, do you want your kids to be the ones, the kind of guinea pigs for? So, anyways, all of that that I'm saying is a lot about, how dystopian futures sometimes do come true, and especially because the ethics of AI is very underdeveloped. So we are seeing right now in all this conversation about Facebook and Cambridge Analytica and all of that, how things can go like terribly wrong when you have enormous amounts of data in the hands of, you know, people with no oversight and no regulation, and this kind of wishful thinking that everybody is just, you know, going to be nice, and so, you know, what kind of dystopian futures can come true, I'm going to talk about at the end. But, you know, maybe we're already living a dystopian future with, you know, like Brexit and Trump and all of those kinds of things, which was in a way originated by a lot of those, you know, the use of those unregulated algorithms and all of that. So a few, you know, recommendations and ideas about AI in education. Then we're going to talk about the dystopian future scenarios. So, and not placing it at the center of pedagogical practice. So it's, you know, even the CEO of the largest personalized learning company is saying, you know, it doesn't really work in the way we intended. We don't have the map, we don't have the assessments with high resolution. So not placing at the center of pedagogical practice, not using it for, you know, summative assessment, this kind of high stakes assessment. You know, being aware that they are optimizing for a very specific objective, and not, you know, the computer doesn't know the, you know, the causal explanation of why a child is, answering a question right or wrong. It's you know, there's no causal chain there. And, you know, leaving space for human interpretation of results. And of course this implies that we need policymakers in the US or in Brazil to understand what AI is and what it can do, right? AI is just like, you can call it, you know, fancy statistics, or I don't know, maybe you have ideas of, but I mean, the brand AI or the word AI is very, in a way, misleading, because of course there is AI that looks like human intelligence, like robots that can walk and do things like that. But, you know, AI in many applications is just kind of statistics on steroids, right? It's just like statistical models that are fed with huge amounts of data. And you see a lot of times companies and organizations that go talk to policymakers saying, we have this AI system that is better than a human at this and that, and they sell these products to people who cannot consume those things, and so they cannot interpret what's going on. They see a dashboard, like a result of, you know, some kind of assessment, and they assume that, you know, that's the truth, or that's reliable, and, you know, it's not necessarily the case. And the other thing is that algorithms are especially bad at this idea, you know, at debiasing. So we know from, you know, again, from Google and Facebook and all of that algorithms are very prone to biases, because, you know, they are, when they are optimizing their loss function or whatever, they might do things that are completely, you know, unethical or kind of incorrect, morally incorrect. So if you realize that people from a certain ethnicity or a certain gender, that they buy less of a product, or they do whatever, I mean, the algorithm doesn't know what, you know, it will do whatever it has to do to optimize its function. But, you know, we know from, you know, a lot of research that there is a lot of bias that gets either unintentionally programmed into the algorithms, or the algorithms, they kind of train themselves, and they end up being, like, you know, horribly racist or gender biased and all of that. And, you know, that's really hard to detect. So that's you know, another problem for. So you know, this idea that people in a position of power, they need to be aware that AI should help decision makers, not make the decisions for them. And we have this naive and dangerous tendency, especially in the Silicon Valley, or because of the Silicon Valley kind of propaganda, to privilege AI over humans. So if you go, watch TV or you go online, you see a million news pieces or TV programs that they say, oh, the Watson beat humans at what's that game? The word game? Jeopardy. Right. So and then the computers beat humans at chess, and the computers beat humans at what's the other game? Go. So I mean, there is this narrative which is kind of cool in a way that computers can beat humans in different games and different tasks, but there is an unintended consequence of that is that when people don't know the difference between playing Go or chess and detecting if a child learns math, they might just assume that computers are generally better at humans just because they're faster or they have really this really fancy companies or brands behind them and all of that. And it's really hard, you need to understand what AI is and what all of those things are in order to know that, well, detecting a cat in a video is a lot different than, knowing if a kid should learn, genes or traits or, whatever he was talking about there. So, so AI is a tool in the toolbox, not the toolbox itself. So, I want to switch gears a little bit. So, there is this idea, that sometimes I call the iPod miracle, but I realize no one knows what an iPod is anymore. So, an iPod is an app on your phone that plays music. It used to be a music player, but the iPod miracle was, this idea that you had, CD, like music, how we used to consume music. Someone had to, record the music, put on a CD, manufacture the CD, put on a truck, send, the truck would go to the store, you go to the store, you buy the CD, you bring it home and all of that. So it's a really expensive and laborious process. And then all of a sudden when you digitize music, all of that stuff, the truck, the store, everything is gone. You just press a button and you get it for, the price the cost of getting the file to you is almost free, and so you get enormous productivity gains from the iPod thing, or just digitizing music or digitizing newspapers and all of that. But we're realizing that in education more and more, and I showed you the examples of Coursera and the examples of all these other things, that there is no miracle like that. There is no we'll digitize it and it will be free, and everybody will have access to education from anywhere at low cost, at high quality, and all of that. And there are many reasons for that. One is that education is not just about transmission of information; it's about coaching, it's about being aware of face-to-face communication, especially with kids. But the other part is that even AI, it's this really interesting thing that was in the news that Facebook has 20,000 people moderating there. So a lot of what we call AI is actually just people in Asia doing human intelligence for it. So there's hundreds of thousands of humans doing what we call AI, training algorithms, or moderating forums, or looking at YouTube videos and filtering them and all of that. So a lot of that is done by humans. But when you go on YouTube and you go on Facebook, you imagine, that's all computers magically doing stuff. But because of, I showed you that thing on YouTube, the kind of inappropriate videos being shown to kids, because that was happening often, relatively often, even if it's 99% accurate, given a billion users, that's a lot of people that are going to complain. So So even for these kinds of things that are relatively simpler, like filtering videos or moderating things, you need thousands and thousands of people. So even there, AI is not there. But you know, the good thing is that there are some good uses of AI in education. So, for example, if you want people to learn more declarative knowledge, so procedures and routines, you know, simple math skills, spelling, grammar. So, of course, you can use AI for a spelling game or a spelling thing, or you can use to, you know, quiz people or do drill and practice on math, or if you want workers to learn like a security procedure or, you know, how to use a particular software in the company. So there are lots of uses of, you know, AI or personalized learning or those kinds of systems in education that are actually cost saving and that are actually good, but they have to do a lot with the audience. So you know, if it's children, if it's adults, you know, if adults that are, you know, already prepared and kind of have the metacognitive skills to be in front of a computer and learn from it, it's much better. But also if it's more declarative or procedural kind of knowledge, so it's memorizing procedures or memorizing you know, simpler kinds of things, maybe you don't need a person doing it. But that's in K-12 education, it's a very small part of the whole process, right? And the problem, as we'll talk about before, is when you don't understand those limitations and you start kind of advocating for this across the board. So, you know, I've been, you know, in reading about, I've been reading about a lot of those things and watching some interesting documentaries about how those things came to be in our society, especially in the U.S. So, urban planning, for example, you know, I've learned, I was shocked to learn that the car industry, the automotive industry, like 100 years ago, there were lots of efforts to put, you know, really amazing public transportation systems in many American cities, and that there was an active lobby of, you know, the automotive industry to actually cancel a lot of the public transportation plans and to widen the streets, because they realized, you know, if people have great public transportation, they're not going to buy cars. Why would you buy a car if you have great, you know, for example, if you live in New York or Paris, you have one subway every 2 blocks. You don't need a car. It's actually, you know, counterproductive. So there was like an active lobby for decades that actually screwed up American cities, and they are what they are now because, you know, the companies wanted to sell cars. I mean, it sounds like this kind of crazy conspiracy theory, but, you know, and I don't like to believe in conspiracy theories, but I was, you know, I had to believe them after reading and watching all this. So, and the same thing happened with smoking. So if you look at the kinds of ads that, you know, I mean, watch a documentary about what the tobacco industry did to get people addicted to tobacco and all of that. Breakfast food, you know, like, why do people eat cereal? It was completely made up. People didn't used to eat cereal, but then they realized, oh, we can take all this, you know, corn, whatever, and do the, you know, create this food that's almost free, and let's convince people that this is really good for them. So people didn't used to eat any of that, you know, like a lot of the food we eat was just a fabrication of, you know, the industry, and normally because they realized it was really cheap to produce. And then the same thing with social media. Like we had this idea that you know, Google is organizing the content, organizing the world's knowledge for free, and that Facebook is connecting people and making us, you know, making it easier to talk to our friends. That's why we need all your data, because we are a people company, whatever it is. And then we realized they were just like auctioning our data to the highest bidder. So I mean, I'm just showing these things. It's not to scare you, but I mean, the main point of this talk is that, you know, when we were here talking about limitations of AI in education, it's not that I'm against AI in education. I mean, I do research on it, and we do have lots of projects around AI in education. So I think it's a good thing to use, but the problem is that AI and personalized learning in education, it introduces a almost irresistible business model, which is to come up with software that can teach stuff and sell those software, you know, the software to school districts and ministries of education and all of that, counting that people don't understand what AI is and the limitations and all of that, and also hoping that people will only realize after it's too late. And you know, a lot of those things are exactly that. Like 50 years later, you realize, because you know, in the beginning, you know, imagine how many cars were in, I don't know, you know, any city. It was just a few cars. It's not like there was huge traffic or global warming or, you know, life was miserable. Like, you know, if you come from any Brazilian metropolis like São Paulo or Rio, you know, 50 years ago, it's like, yeah, fine. Like, what's the problem of cars? And now we're kind of drowning in cars. So a lot of things you don't realize until it's too late, and then it's too big to fail, kind of thing. So what I see happening is that in Brazil there are two very important things going on. One is the high school reform, and the other is the new national standards. And so, you know, if you start reading attentively the newspapers around this, so you start realizing, you know, what I'm talking about, like this, like echoes of this. So there was a big thing a couple of weeks ago that a big newspaper in Brazil announced that the government was considering offering 40% of high school online, like allowing high school to be done online, public high school, right, to be done online, up to 40% of the hours. And then there was a big controversy, and then they kind of took it back. But clearly, I mean, you know, we go every year to Brasilia, and we talk to, you know, many policymakers and all of that. You know, and it's clear from those conversations that there are huge economic groups that are very interested in using these kinds of things, software, personalized learning, whatever you call it, in very large scale in Brazil, because it's like an unimaginable amount of money, but they need the government to allow them to do it online, because otherwise it doesn't make sense economically, right? I mean, if you have to have a teacher in the classroom, it kind of defeats the purpose. The only way it can really work business-wise is if they can have, you know, a certain percentage of a high school to be done online. So you have, you know, some teachers there still, because if you get rid of all the teachers, it's too much of a scandal, right? But you have 60% of the hours there, and that 40% are online. That's, imagine, like, in the whole of Brazil, how much that is in terms of students and hours and all of that. And then they will come here to the Silicon Valley and buy a few software, you know, like pieces of software from companies that are like Amplify, that they are, you know, themselves realizing it doesn't work, but no one will quite know. And then go to Brazil and do those kinds of big reforms. And especially in Brazil, no one will care, because the middle class doesn't go to public schools, so it will be, you know, public school students doing high school, that's already bad. Now online, it's going to be even worse. And then they will say, well, but you know, we bought the best software from the Silicon Valley, and you still can't learn. I mean, you're really stupid. I mean, the students will get blamed, because they will be, you know, people say, no, this is like the best stuff from Silicon Valley, from Google, from, if you can't learn even now, it's your fault. So I just want to wrap up saying that, it's not about like being against or for technology, but I think we need to, when we're talking about public education, especially in a place like Brazil, we have to be very aware of those, the dangers and the risks of adopting unproven technologies, especially technologies that are in the US now being recognized as very limited. And we see a lot in the center here that people come and they come for, they visit the Silicon Valley, they visit Google and Apple and all, and they go back to Brazil kind of mesmerized by technology. And it really worries me that one of these days, we'll have some of the regulations that we have in public education, for example, for online learning and K-12 education being relaxed, and then this kind of dystopian future of kids, in front of computers, not learning anything, while kids in the private schools in Brazil are having, the best and greatest education. I don't think it's far-fetched to think that could happen, because in Brazil that happens in so many other fields. I mean, in healthcare and all of that, it's so easy to ignore and kind of build walls around, certain areas of things, and live in this kind of make-believe world that we sometimes have in Brazil. So I think it's something that we need to really pay attention to. And so we still have some time, so we'll just leave some time for questions. But thank you.